All right, so this last video of the year, at least for 2020 fall, is all about graphing parabolas. So first they're going to have you do kind of the easy stuff, which is use the graph of the parabola to fill in the table. So they're giving you a parabola that's already graphed. Okay, so this is kind of a vocabulary and just an awareness. So the first thing you want to do when you look at a parabola is note the direction. So it's going downward. Oh, wait, you know what I'm going to do so I don't screw up here? I'm going to lock everything. Good. Okay, find the intercepts. Okay, the intercepts are where it crosses the x and the y axis. So the x-intercept right here is hitting it at -2. -2, 0 is really the point, but we just give the point because we know it's a 0. So we just give the x coordinate rather than the whole thing. On the y, it's going through -4. So the y-intercept is -4. Find the coordinates of the vertex, and that would be -2, 0. You just need to look, and that's just asking you whether or not you know the vertex, like the word vertex. Find the equation of the axis of symmetry. Now, the axis of symmetry is an imaginary line that basically goes down through the vertex, okay, that is where, well, you could basically fold the parabola on top of itself there, okay? So as you can see, this is going to be x equals -2. X equals -2 because an x line goes straight up and down. You can see that x is always -2. -2, 1, -2, 2, -2, 3, -2, 4, whatever. Okay, that's the equation of the axis of symmetry. It's always going to be x equals whatever the vertex is, whatever x value the vertex is. Okay, let's try the next one. I think I did 2 of all of these, okay? So let me do this real quick. Move it up. All right, let's try this again. See if you guys want to try it, you can pause it and see if you can do it yourself. Let me go ahead and pick the orange. All right, so this one, again, it goes downward. That one's not too hard. Axis of symmetry is right here. Again, it's x equals -2. You can see that it goes here. The only reason I'm not drawing it is it's really hard for me to draw. We usually draw the axis of symmetry with a dotted line. And what's really weird when you guys work on Alex is that you don't usually typically have to draw it. I find that very strange. It's usually one of the very first things that you draw when you're doing it by hand. You draw, usually when you're graphing a parabola, you usually graph the vertex and then the axis of symmetry immediately. All right, find the intercepts. Well, there you go. The x-intercept is none. There is no x-intercept. It does not cross the x-axis in any place. And the y is -6. The coordinates of the vertex are going to be right here, and it looks like it's at -2, -2. So make sure you put it in parentheses. Wow, that was weird. -2, -2. All right, let's try the next one. Okay, it says graph the parabola in the form. Now this is vertex form. Y is equal to x minus hk. Now I know we did this and we played with it on Desmos, okay? This is the vertex. The vertex is hk. Now notice that it says minus h. Minus is in the formula. That minus is part of the formula. So the h is always the opposite of whatever's in the formula. It's basically what gives the 0. So like if you're looking at x minus h squared, this is the piece that's h. The minus sign needs to be there. So if it says x minus 2, the h is actually 2. Okay? If it says x plus 3, that's basically x minus -3. See? Because we need the minus for the formula. So that one would be -3, whatever the y is. The y, on the other hand, is plus k. So that whatever the k is always the same. Okay? So in this case, let's take a look at this example. Okay? The vertex is for -2. You always take the opposite of this one and the same of that. Okay, but the reason why is because you're basically finding the zero. What would make this zero? That's really what you're asking. If you're trying to be a little bit more advanced mathematically, 4 minus 4 is 0. Get it? Okay. All right, moving next. Try this one. What would be the vertex here? Okay, the opposite of -1 is 1, and then -5. That's it. Easy enough, right? Oh, wait, this one says graph a parabola. Was the last one graph a parabola? Oh, oops, I'm sorry, guys. There's steps to this. I was not paying attention. I was like, I thought it was naming the vertex. Okay, here's the directions. This is how we graph a parabola. You need to plot 5 points. You have to plot the vertex and 2 points to the right and 2 points to the left. Okay? So this is 2 points to the left and 2 points to the right. Okay? So the first thing you're going to do when you come here, I'm going to try to draw a straight line. That didn't work. Sorry, if I don't have my like tablet exactly right, it's really hard for me to draw straight lines. Okay, so here's your X, here's your Y. Okay, the first thing you want to do is graph the vertex. So we're going to graph it at 1, 2, 3, 4, -2. So mark that point, okay? Then it wants 2 points, 2 to the left and 2 to the right. So if you were doing a table, this is how you would do it. X and Y. You would plug in 2 to the right and 2 to the left. By the way, the axis of symmetry is right here on 4. Okay, so 2 to the left would be at 3 and 2, and then also 2 to the right would be 5 and 6. Okay, so if we plug in a 3, here's what we're going to do. I'm going to go ahead and draw this out, okay? I'm sorry for this ugliness, y'all. Trying. Okay, here's what we're going to do. We're going to go x minus 4 quantity squared minus 2. So we're just going to plug this in, okay? I'm going to change colors for myself, okay? We're going to go 3 minus 4 because we're plugging in the x squared minus 2. That's -1. Okay, -1 squared is 1. 1 minus 2 is -1. This one, 2 minus 4, quantity squared minus 2. 2 minus 4 is -2. -2 squared is 4. 4 minus 2, 2. Okay, next one. 5 minus 4, quantity squared minus 2. 5 minus 4 is 1. 1 squared is 1. 1 minus 2 is -1. And then 6 minus 4, quantity squared minus 2. That's 2. 2 squared is 4. 4 minus 2 is 2. You will see some symmetry, and you're supposed to see symmetry. So 3, -1. 2, 2. Okay. Now, you can also graph the first 2 points like this and then just reflect them. Okay. I mean, that's possible. You can always do that, or you can just figure out the math on the 5 points. Okay. And that's all you have to do. For you guys, it's a little nicer. You don't even have to draw that, but I'm really impressed with myself. You guys, that was really pretty. I'm going to say that was really pretty. Okay, I'm going to graph it on this side here this time. Whoa. It didn't even know I wanted a straight line. It was like, you suck. Okay, here we go. Boom. All right, X and Y. Always label your axes. Okay, first the vertex. 1, -5. So here's 1. And always label that, okay? 1, -5. Okay, and then you draw your axis of symmetry. Okay, you won't be able to draw the axis of symmetry, but it's very strange if you're doing it by hand to not draw it. All right, so here you go. Then we're going to make a table, X, okay? And then we're going to plug in X minus 1, quantity squared minus 5, and then we're going to pull out the Y, okay? And they want 2 to the right and 2 to the left. Okay, so 2 to the right, if we're at 1, 2 to the right is going to be 2 and 3. And 2 to the left is 0 and -1. Here, 0, -1. All right, so, hi, babies. My kitty just came in. All right, so we're going to plug it in. 2 minus 1, quantity squared minus 5. 2 minus 1 is 1. 1 squared is 1 minus 5 is negative 4. Let's plug in a 3. 3 minus 1 squared minus 5. 3 minus 1 is 2. 2 squared is 4. 4 minus 5, negative 1. 0 minus 1 is negative 1 squared is 1 minus 5 is negative 4. Okay, see how easy these are to plug in? They really aren't that tough. Negative 1 minus 1 is negative 2 squared is 4. Minus 5 is negative 1. So you go over here and you get 2, negative 4. And you get 3, negative 1. And if you felt like it, you could have just reflected it. Okay, I went ahead and did it both ways, you guys. I went ahead and showed you how to find it by plugging in the points. And I showed you how to just reflect it. When you're reflecting it, you go, oh, I graphed that point. Well, that point's just one, the same distance. See, this is 2 away. This is 2 away. Okay, next. See what we've got here. Next. Thank you. Next. Just kidding. Okay. Graphing a parabola in the form. Now this is, okay, this is called standard form. Okay. When you are given standard form, you only need to know this. Why, that the h is equal to negative b over 2a. That is how you find h of hk. Once you find h, all you do is plug it in to find k. Okay, so for example, identify a, b, and c. A equals 1, b equals negative 10, and c equals 27, right? All right, so h equals negative b, which is 10, negative 10 is positive 10, over 2 times a, which is 2. So you get 5. Okay, so we know that the h value is 5. Plug it back in to get y, because it says y is equal to. So plug back in x squared minus 10 times 5 plus 27. Y equals 25 minus 50 plus 27. Sorry. You know what it usually ends up being, you guys? These two end up being able to be added, and they're really close to that one, typically. Y is equal to negative 2 or positive 2. Positive 2. Because 25 plus 27 is 52. Minus 50 is 2. So there you go. There's your vertex. All right. So now when you come to graph it, I'll see if I can graph a straight line. Thank you, program. That was pretty cool. Okay, 1, 2, 3, 4. Wow. Wow. I'm sorry, guys. You just have to deal with me, but okay. This is your line, 5, 2. Now you need to find, let's find 4 and 3. Okay. So let's go ahead and find, I guess we'll do x and y, and we're going to plug in 4 and we're going to plug in 3 because those are the two to the left. And then we're just going to reflect it. Okay, so if I plug in a 4, I get 4 squared minus 10 times 4 plus 27. Now you can just put this into a calculator, you guys. I don't, but you could, right? So this is 16 plus 27. Sorry, I don't have a calculator handy. So is 43. 43 minus 40 is 3. Okay, so you get 4, 3, which is right here. 1, 2, 3. Okay, you should always label it. Okay, so, sorry, this is 3. And then this is 9. 9 plus 27 is 36. And 10 times 3 is 30. So it's going to be 6. So that's 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. 3, 6. Okay, and then you can just reflect it. This is 2 away. So there you go. This is 1 away. There you go. If I were to do that. And oh my goodness gracious, just bear with me. There you go. Okay, next. I know I'm working these fast, but I'm assuming there's somewhat of a review for you. All right, so graph the parabola. Okay, here in standard form. So h equals negative b over 2a, which is positive 4 over 2, which is 2. Okay, then we have h. Plug it back in to get k. Plug it back in. So we're going to go, I'm going to go do it here. Sorry, it's weird because I'm plugging it in weird spots, but just bear with me, you guys, because I don't have a lot of space. 4 times 2 minus 1. Whoa, let's not do that. 2 squared is 4. 4 minus 8 is negative 5 minus 1 is negative 6. Okay. Again, I'm not teaching all that basic stuff, so you guys should be okay. All right, so now that you have the vertex, and the vertex is at 2, negative 6. 1, 2, 6. Okay, and hey, I kind of drew my axis of symmetry. By the way, this is positive, so it's going to go cup up. Okay. Then we go, let's go ahead and find the points. If we know that the x value is at 2, I'm going to pick 1 and 0, okay, to plug in. I'm going to pick in 1 and 0. If I plug in 0, I get negative 1. That's the easiest one, okay? And then I can reflect it over. If you don't know what I'm doing, just plug in 3 and 4. Okay, and then let's plug in 1. 1 minus 4, negative 3 minus 1 is negative 4. So 1, 2, 3, 4. 1, negative 4. Okay, and then I'm going to reflect that over to this one. And then you just connect them. And I'm sorry, I didn't connect them. Okay. All right. It says find the x-intercepts and coordinates of the vertex for the parabola. Okay. Now to find the intercepts, you need to factor. Factor it. Set it equal to 0. Okay, set it equal to 0. So you go, because look, you guys, the x-intercepts y is equal to 0. So you take, oops, wrong. Hang on, let's put x squared. X squared plus 4x minus 21. We're going to set it equal to 0. And then we're going to factor this because we want to know what values of x make it 0. So we're using the 0 product rule again, and it's so cool. X times x, 21. 3 times 7. 3 times 7 will multiply to get 21. If I do a positive 7 and a negative 3, I'll get negative 21 when I multiply. Oops, positive 7, negative 3. So x is equal to 3 and x is equal to negative 7. Those are the intercepts. Okay. Does it want the y-intercept too? Find the x-intercepts and the coordinates of the vertex. Okay, so vertex again, negative h, h equals negative b over 2a, which is negative 4 over 2, which is negative 2. Then plug it in. Be careful. K is equal to negative 2 squared. Put it in parentheses. 4 times negative 2 minus 21. Just plugging it back in. K equals 4 minus 8 minus 21. Woo! Is that real? Negative b over 2a is definitely negative 2. That is a positive 4, negative 8, and a minus 21. Woo, that's weird. Oh, okay, we don't have to actually graph this, so that makes it a little bit easier because that's 29. Well, it's negative 4. It's negative 25. Okay, so the vertex is at 2, negative 2, negative 25. And that's all they asked for. Okay, let's try one more. Set this equal to 0. Okay, I got to teach you a cool trick right here. You see how that has a stupid negative in front of the x squared? You could literally move everything over to the other side or just divide everything by negative 1. Both sides, the entire thing, and you get 0 equals x squared minus 4x plus 4. It's my favorite trick. I don't have to move anything. All I need to do is change all the signs. This is a perfect square trinomial, whether or not you recognize it. There's only one x-intercept, okay, because they're the same x-intercept. And then, of course, the vertex, I'm going to leave that to you. You know how to do that by now, I would think. Okay, here. Okay, when you have a quadratic, it can either go like this or it can go like this. Okay, if it goes like this, then this point right here is called a maximum. And if it goes like this, it's called a minimum. Think like you're on a roller coaster and you go up and you go to the highest point. That is the maximum. Now be careful because they're not asking you about the x value. They're asking you for the y value. Y value is the maximum. Whenever they ask you for the value of the function, remember when I say function, you say y. The y value is the value of the function, okay? And the minimum, again, you're dipping down. Woo! This is the minimum, all right? So does the function have a maximum or minimum? Here's how you can tell. If this is a negative ax squared dot, 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 okay? If that's what this is, if there's a negative, if a is negative, it goes upside down. If a is positive, then it goes up. Okay, so if it's upside down, it has a minimum. So this is upside down. So, I mean, it has a maximum rather. So it has a maximum. I always just draw it. I don't try to memorize this crap. I just draw it. I'm like, oh, it's upside down. I'll draw it. Oh, it's a maximum. Where does the maximum or minimum value occur? Okay, so basically what they're asking you for is the vertex, and they're asking you for the k. So all you need to do is do your h equals negative b over 2a thing, which is negative 6 over 2 times negative 1, which is 3. Then you plug in the 3, f of 3, and you plug it in and you get negative. Do not put it in parentheses with the negative. Remember, x is not part of that negative is not part of x. Okay, plus 6 times 3 minus 13. That's 18, negative 9 plus 18 minus 13. That's 9 and 13 is 20, 22. 7. Take 7 away from the 9 to make 20. Yeah, 22. Okay, so it's negative 4. So answer is negative 4. Okay, I'm sorry, I don't have room, so I'm going to put it here. So the vertex is where does it's the x value. Where does it occur? That one, they're not asking you for the value, they're asking for where does it occur. So that's the answer is 3. And what is the maximum or minimum? Negative 4. Okay, let's try that again. Okay, it's a positive, so it goes, woo. Okay, it has a minimum because it dips down low and comes back up. What is they're gonna, by the way, they're gonna change the order that they ask these questions so that you don't get all like comfy in answering them. So what is the function's minimum or maximum value? That's what they're looking for. That's when they're looking for k. When they ask you for the function's value, that is k. When they ask you where, they're basically saying, hey, where on this x does this max or min happen? Okay, so again, here you're going to find that, you're going to find, hey, come on, honey, what's wrong? It won't write anymore. Well, that's really timely because, oh, there it goes. Okay, H. Okay, and I don't need to do that. I've done it so many times today. And that's it for this particular, not video. I'm going to have to go over here because we have a couple more to do. Okay, a couple word problems. So in the word problems, all I want you to do is look for the equation. That's all you need to do. Look for the equation. And then they're going to tell you what C equals, and they're going to tell you what X equals on this side, okay? So it says C is the cost in dollars, okay? So this side is money, okay? X is the number of cars made, number of cars. So what they're telling you is that the cost is dependent on the number of cars, all right? Then all it's going to do is ask you to plug in some stuff, okay? Or find or graph this thing and figure out what the vertex is, honestly. If X cars are made, then the unit cost is given by this function. What is the minimum unit cost? Okay, see, it's positive. So it goes like this. Believe it or not, if they make very few cars, the cost, it kind of makes sense. Think about this, you guys. It never gets to 0. That's a stupid graph here. Maybe like this. Okay, and maybe it's like way dippier. Maybe here, let me see if I can, guess what? I can't do it. I can't erase it, else I'll erase my problem. I'm thinking maybe it's way more like this, like really subtle. Okay, because if you make a few cars, they're more expensive. But the more cars you make, okay, they get less expensive. Okay, I don't know why they get more expensive as you make more cars. I would not have predicted that. Okay, anyway, it says, what is the minimum cost? What is the minimum unit cost? Okay, so what are they asking you for? Okay, when they say minimum, They're asking you for the K. So all you have to do is, actually, you want to know what you could do? You can go to Desmos graphing, find the vertex, and then just get the X. I mean the Y value of the vertex. Okay, because they're asking for the minimum cost. So you know that's a Y value. So if you wanted to, just plug that into the graphing calculator and get the vertex. But if you didn't want to and you wanted to do it old school, it's 374 over 2 times 1.1. You plug that into your calculator. I'm going to use my phone calculator, you guys, just because you can use your phone too. Okay, so let's do this. Calculator, I'm turning it sideways. 374, I don't have to, but it makes me more comfortable. Divided by parentheses, 2 times 1.1, because I'm on an iPhone calculator. Okay, so that's 170. Okay, that is my H. I need to plug that in now. So I'm going to find not C, not F, but C of 170. So 170 cars is going to be the minimum cost, okay? Seems like very few cars. I don't know. What kind of cars are we making here? This doesn't make any sense at all. I want to know what kind of car. What manufacturer? What? Okay, 374 times 170 plus 36,400. And then you just plug it in, literally. So 1.1 times 170 squared plus, minus 374 times, and I don't need to actually put parentheses because my calculator knows how to do PEMDAS, 36,400, 4,610 is the answer. 4,610. Boom. That's all you had to do. Plug it in. Plug it in, plug it in. Okay, here we go. So last problem, I think, unless we might have a ball problem. Let's see. Can't remember. I made these boards a while ago. Okay, so here again, cost, X-ray machine. Problem. What is the minimum unit cost? Okay, if they're asking for cost, they're asking you for a Y, which means if they're asking you for the minimum, they're asking you for K. Okay, so again, all you have to do is find your H with a negative B over 2A, or like I said, you can go to Desmos. Okay, let's go to Desmos graphing. Okay, I'm going to go to Desmos graphing calculator, and we are going to plug in Y equals, I don't even think you have to put Y equals, by the way, you guys, did you know that? I'm pretty sure all you have to do, okay, 0.8x squared, 0.8x, let me get the square, boom, give me that square, give me that square. And I'll keep doing this, let's do this one. Minus 320, okay, minus 320x, okay, and then, sorry, I have low brain power for actually memorizing, talking, and doing all this. 46,170 plus 46,170. Okay. And, oops, did I put 0.8? Isn't it 0.08? No, it's 0.8. Okay, so back here, okay, we can put this down. Boom. Hopefully we can find this sucker because remember, look, our Y has to be at 46,000. That's our Y-intercept. Wow, guys, we need to get way out here. Okay, so look at how it's going really sharp up. I think if I pull in, I thought I could pull out like with my fingers sideways and it would make it wider. It doesn't seem to be working that way, but here's the vertex right here. Let's see, there you go. 214,170. So what are they looking for? They're looking for the Y answer, minimum cost. So the answer is 14,170. I don't care if you use a graphing calculator. Psh, more power to you, people. I think that's it. All right, that's it for this last video.